Hey, welcome to your Level 2 Regents review. In this topic, we talked all about congruent triangles and also finding the angles in triangles, but mostly about congruent triangles. So let's review the 5 ways we can prove triangles are congruent. There's side, side, side. There's side, side. There's angle, side, angle. There's AAS, and then it says nothing else. But usually I do this in person, and someone's like, no, there's one more. And that's correct. There is more. You need to be able to recognize that. The last one that we have is HL, which you might remember is when you have a right triangle and you have a congruent leg and a congruent hypotenuse, right? Like that. So those are the 5 ways to prove congruence. The other 2 major things that you learned in this unit was about the isosceles triangle theorem, which is the base angles in an isosceles triangle are always congruent. And we also found out about how the order of how these letters is really important. And this is something they do a lot on the Regents, where they check you on this. So for example, because of the order of these letters, triangle ABC is congruent to triangle DEF. We know angle A is congruent to angle D because they're in the same position. We know angle B is congruent to angle E, if that was there. And we know angle C is congruent to angle F. All right, those are the major topics. You could also say that AB is congruent to DE because they're in the same position, and so on and so forth. So those are the key topics that you learned about in this unit. And then you had some key vocabulary. And these are like the big 5 that you need to know. You need to know that an angle bisector is a line that divides an angle in 2 congruent parts. Now, a segment bisector is the same thing. This is a line that divides a line in 2 congruent parts. The median of a triangle, I'll draw it out first. A median goes from the vertex down to the midpoint of the other side. So this is a line that divides the base in 2 congruent parts. And then the last 2 are altitude, which is, I'll draw this one. This is a line that goes down. It doesn't go to the middle, but it makes a 90-degree angle. So this is a line perpendicular to the base of a triangle. And then finally, what is perpendicular? Well, that's 2 lines that form 90-degree angles. So those are the main things that you have to know from this unit, okay? You have to know these definitions. You have to know the 5 ways to prove congruence. Now let's do some practice problems. The first one, before going into proofs, we're going to just remember how to find the angles in a triangle, all right? We call this angle chasing. The question here is telling us a few things. On the top, it says that LMO is an isosceles triangle with LO congruent to MO. Remember, the first thing you always do on these problems is mark your triangles. So now we know it's an isosceles, and also it told us. It tells us that L is 55, NOM is 28. What is the measure of angle N? Justify your answer. So when you justify your answer, you might remember we have to make a chart here. And that chart should have angle, measure, and reason. All right, that's how we justify our answer. So for example, if I fill in any angle, I'm going to say how I knew those things. So the first angle I'm going to fill in is the ones I know. So the measure of angle L is 55 because it's a given. And the measure of angle NOM is 28. And I know that because it's given. Now let's start filling in the more interesting angles. For example, since this is an isosceles, I know these 2 base angles are congruent. So I could say that angle OML is 55 degrees because base angles of isosceles triangles are congruent. All right? Then I can use linear pairs to find out that angle OMN is 125 degrees. So angle OMN is 125 degrees because linear pairs are supplementary. All right? Remember, that's just 180 minus 55. And then to find angle N, we'll just use the triangle sum theorem. So we'll just do 180. So this is our triangle right here. 180 minus 125 minus 28. All right, and so angle N, we know is, if you do 180 minus 125 minus 28, we get, let me see, I'm trying to do this in my head, 27 degrees. All right, and that's the triangle sum theorem. So that's our justification, and then we just say angle N equals 27 degrees. And that's how you do a question like that. Okay, so now we'll start going to our proofs. The first proof is very easy. The second proof, well, that's a little bit more challenging. So let's look at the first one. Now, let's just go over the steps on how to do it. The first one gives us a bunch of information. It says BE and AD intersect at point C. It says BC is congruent to EC, AC is congruent to DE, and it tells us AB and DE are drawn. So the first step to doing any problem like this is to mark your givens. So the givens are BC is congruent to CE, and AC is congruent to DC. Those are our givens. Now that we have our givens, we should start throwing in other things that we know are true. Like, for example, we know that BCA is congruent to DCE. All right? Those are vertical angles, and vertical angles are congruent. And now looking at these triangles, we could say that these two triangles that we have are definitely congruent because of side angle side. All right? So let's start writing our proof. So we filled in our givens and the things that we knew, such as vertical angles. And now we know we're going to write out our statements and our reasons. So, first statement. We're going to say that BC is congruent to EC. That's one, that's a given. Two, we know AC is congruent to DC. And we know that's also a given. Three, we know that, you know what? I'm not going to write these out, but you should also add in these other two givens. All right? So put those in there. For time, I'm not going to put them in. Three, we're going to say that angle DCE is congruent to angle BCA because of side angle side. Sorry, that is so wrong. Don't say side angle side congruence. Because of vertical angles are congruent. Vertical angles congruent. And then four, we've basically actually stated everything in our triangles, right? We've talked about why the two sides are congruent. We said why the angle is congruent. We've got our three things. So now we could just say what we were trying to prove. Triangle ABC is congruent to triangle DEC because of side angle side congruence. All right, that was a piece of cake. So let's try the second one now. This is the real one we want to take a look at. So number two. It says triangle ABC, BD bisects angle ABC, and BD is congruent to AC. So let's start off, and it says prove AB is congruent to CB. Remember, this is a CPCTC proof because it's telling us to prove a part is congruent. So let's mark our givens. One, it says BD bisects angle ABC. Well, angle ABC is this angle right here, and it's getting bisected by BD. So if that's what's happening, if this angle is getting bisected, we know that an angle bisector cuts an angle into two congruent parts, like so. All right? Now we also know that BD is perpendicular to AC. So AC is here, BD is here. Perpendicular lines intersect to make 90-degree angles. So let's go like that. And then finally, even though it's not given, we have the reflexive property because there's a shared side. So we'll go like so. So that's angle, side, angle. So now that we've proven that the two triangles are congruent by marking them, let's actually write out the proof. So we have statement and we have reasons. First statement, BD bisects angle ABC. We know that because it's given. Two, BD is perpendicular AC. We know that's given. And now we got to start saying what we have marked. Okay, so three, I'm going to say that BD is congruent to BD. That's the reflexive property. Remember, that's a side's congruent to itself. I'm going to say that 4, angle CBD is congruent to angle ABD. That's an angle bisector. Divides an angle in two congruent parts. 5, so now I've talked about the side. I've talked about the angles. I got to talk the right angles. And remember, the right angles are always two steps. So first I'm going to say angle CDB and angle ADB are right angles. I know that because perpendicular lines form right angles. And then 6, now is when I could say they're congruent. Angle CDB is congruent to angle ADB because of all right angles are congruent. All right, final 2 steps. 7, we now know that the 2 triangles are congruent. So we're going to state triangle ADB is congruent to triangle CDB because of angle side angle congruence. And then finally, 8, we know that AB is congruent to CD because of CPCTC. Wow, that's it for this video. Now, I'm going to go check on Miss Hirsch's room because I don't know what's going on in 7th period, but it sounds like it's a lot of fun. So I'm going over there. Peace.